Welcome back, guys. This will be day 10 of me trying to learn TypeScript. So yesterday on day 9 I was doing type narrowing, but I finished on level 5, which was predicates, I think, like where you would have to like use a helper function to narrow your function, like using the syntax value is then the type you are trying to narrow, whatever. Okay, so this will be day 10 of me continuing with chapter 10, and I wished we were like hitting chapter 13 so that I can finish and get to the good part, which is writing an HTTP client. So that's that. We're just gonna read. Hope the reading is getting better. Yeah. Okay, exhaustive checks. If you ever had a Rust enjoyer, let's be honest, if you know one, you have heard from them. Of course. Talk about other great Rust programming languages. You've heard them talk about how great the Rust programming language is. You probably heard them mention pattern matching and exhaustive checks. Okay, exhaustive checks. To be fair, it's pretty cool. It's a pretty cool idea. Say we have this union. Okay, let's see. Maybe we're learning Rust 2 in the process. Yeah? Say we have this type union, of course, and we have this function that uses it. Native capital, native. If it's email, we do that. SMS, we do that. Okay, unknown notification type. This might be a very reasonable way to write JavaScript code, but the final return and notification type is actually redundant in good TypeScript code. The switch statement is exhaustive, and TypeScript is smart enough to know that return unknown notification is actually unreachable code, and it will give a compiler error. Because this function won't allow you to pass anything else, right? Somebody's blasting music right now. People at rest. Yo. Okay, okay, yeah. It's actually unreachable code and will give us a compiler error. As the moment we have configured TSC to do so, design your type so that you get these kinds of useful errors. Okay, this will be unreachable, so you just remove this. So like, because TypeScript, everything is checked here, and it won't allow you to pass something that won't be checked, right? That is not of the type, right? Design your type so that you get this kind of useful errors. As I meant, the increment count function is working as intended at runtime, but someone committed an unnecessary default case that throws an error. Remove the unnecessary code. As I've said, we just remove this code. Guard clauses, a fancy way of saying early returns, are my favorite way to quickly narrow types within a function. Peak production TypeScript code is often riddled with undefined and null types due to the nature of IO and external API. So this is a classic pattern. So function process names, taking a string. Oh my god, null or undefined. If it's null or undefined, we just return, and then we can do whatever we want to do here. Okay, TypeScript null names a string here. Now an empty string keep process name. Okay, now an empty string keep process names behavior straightforward, always returning a string, but depending on your use case, it might make more sense to throw an error instead. Okay, just instead of like returning an empty string, it might make sense to return an error, whatever your use case that will be up to you. But to taught us that this is what peak production code looks like. Okay, crafted by a genius. Okay, when you're working with IO and like external APIs, you might want to like check for every case. Okay, interestingly, throwing an error still narrows the type, but it doesn't change the function signature. This function still just returns a string. That's because errors in JavaScript and TypeScript are a control flow mechanism, not a type mechanism. So you do not just kind of need to be aware, hey, this function can throw. I need this I need to handle that. Okay, in cases where my programs won't break on an empty string, I might just call colleagues, whatever that is, an empty colors, an empty string instead of throwing an error. This happens all the time with optional fields in web apps. Okay. Yeah, like when you're working with like I see. Saying like it's not a problem to yeah, to do that empty string, whatever, instead of throwing an error. Yeah. We at Support AI value customer feedback, or at least that's what we tell our customers. This guy is full of jokes, man. Complete the end of feedback function. It takes user feedback as an object and validate it. Add some guard clauses to narrow the undefined away. So let's see. We need to let's see. Things as an object and validate. Add some guard classes to narrow undefined away on the AP path when it returns on its way to the AP path when it returns the given Thanksgiving, whatever. Okay, this is another function. This is valid. Rating is it's crafted for production. If the string is undefined or is not valid string, use the helper type predicate function. Return the string, give a rating between. Okay, let's see. It's valid rating. Okay, so we'd use the it's unvalidated. Use the helper type predicate function. Okay, this is the type predicate. Where is it? This one. If it's not a valid string, we'll use the if rating is. But this is checking for numbers 1, 2, 3, 4, 5, and then check if it is 1, 2, 3, 4, 5. Then return true if it is, false if it's not. If the email is undefined or it doesn't include a @ symbol, return a string, provide a valid email address. So yeah, maybe I'm gonna code now, because like I'm kind of lost. Okay, so it's taking in user feedback. Okay, we might want to do this. Okay, so we might want to do this so that we can see what we're doing. Okay, so let's just do this for now. Okay, let's just remove this. Okay, so the function takes an object of this, which might not be there. Okay, let's just do I think undefined, and then okay, let's just do if feedback undefined, then we'll return. What are we supposed to do? Let's see. Let's to narrow the undefined away on the AP path. Okay, if the rating is undefined, where is rating? If rating, but like okay, rating is taking an email and rating. Okay. If the rating is undefined, it's not valid rating, use the helper function to string to return, give a proper rating. Okay, so we'll do this here, and so if is valid, and then we pass in the feedback dot rating. Yo. Yeah, we're passing in what are we passing? Rating. Yeah, we're passing in a number. So why is it crying? Argument number is not assignable to parameter of type number. But we have already checked undefined there. Why can't they just allow us? So like you would want to check if it returned false, and then we'll return, fix that later. We'll return the string, okay, or to fix that. Undefined. Okay, let's do this. Okay, hey, we are fixing errors. We're not playing pig production code. Okay, if the email it doesn't include a return string, provide an email. So here it would be, where's get user email? Get email user. Okay. So would what would we return? Would return in here, right? If feedback is undefined. What am I doing? Okay. Doesn't include an @ symbol. Provide a valid email address. Yeah, we'll check then if it's -1 index, or then we'll return whatever email address. But this is throwing an error because it's unable to type parameter. So we'd need to like do dot email and or feedback dot rating is equals to undefined. If there's nothing, what do we return? Okay, whatever. Yeah, let's just return an empty string and not throw an error. If the given rating is not right, then we'll ask the thing, okay, let's remove this, man. We'll tell the user that they need to pass in something that is between 1 and 2, and then do we check here or do we check here, like for -1? So this at index, okay, okay, let's do if get dot feedback dot rating, right? Okay, yeah, putting the string, yeah, rating. Is it no, email, then we return this string, right? Yes, they will return that string. There is everything is fixed. Then the function I think is called end of feedback. Then we'll console log end of feedback. Come here, check what we want to pass. Feedback is an object. Erika. Marita. Señorita. Okay, let's run and see. Provide a it just return things, man. Provide a valid. No, wanna do. If it doesn't, let's see. But these things, so okay, like this will be true, of course. So like wanna like this when the index was -1. Okay, so okay, now what does the function return? return index. If index is -1, it's not -1, we return the email that supplies warawara, or we return the email. Okay, so if the email had did not have the thing, where the get user email, if the email did not have the thing, then this will be equal to feedback.email. Right, now we just yeah, then to print thanks, Franklin rating good. Yeah. Okay, so let's just pass it. Let's move on. How much time did I spend? Type assertion. Sometimes you know more about the value type than TypeScript does. Okay, it's rare, but it happens. As the S keyword is the trust me bro of TypeScript. Of TypeScript. Imported dev code base, we have some places where we know a query parameter is a string, but Vue, our front-end framework, is a string for query parameters, which makes sense because query parameters can be arrays, but we know in many cases, because our backend controls this, that is always a string. So we have something like this. A property to lowercase does not exist on type string. Okay, because you can do to lowercase on a string. So user ID routes.query. What is this asking? Routes.query. User ID to lowercase. But we know it's never an array, so we use a string. So we do this a string and then to lowercase. Okay. We also capture the values that come across the network as unknown, and then use S to assert them into the shape we expect a given network. We expect a given network response to be. If you have like this type ID name, the function taking a string, returning a promise of some type, then response await fetch, and then hitting the endpoint, then it returns like some JSON function as an wait, which waits for get raw data, calling this function. Here data is still just unknown, so we assert data to type user. Okay, return data as user. Okay. Angle bracket syntax. There's an alternative syntax for type assertion using angle brackets and the type and the type before the value. So there's this and then we'll do this. Okay, so we don't have to say a string. Why would we say a string? I think you know the syntax, but like when you try to remember the syntax, okay, we just write everything and then after user ID a string. So we do a string here. Okay, so but now we can just do this angle bracket syntax. When to do type assertion, try to avoid them. I can see why. I'd rather use actual conditional narrowing over assertions unless I'm extremely confident. Conditional narrowing is safer because it doesn't involve assumptions. I prefer the S syntax over the angle bracket. Bracket syntax is clearer, easy to read, and easier to write. Assignment: we use a third-party service for handling payments, and although we can't have type safety on incoming data, we do expect that it comes in a consistent format. Fix the function handle successful order by asserting that the order response is in fact the order response is in fact some order data. Leave the unknown in the function signature. Let's see. Marita. Funa Marita. Ne utonga hati barikani. rakata as if bass in the lead guitar. So we're doing some type narrowing, type accession, right? So when I create a new file, just name it accession.ts and then copy paste the code. That's that. And then he says that we want to. So here do we do as user feedback? No. It's order data now. Like we don't do it like this, nah. Oh, do we do as order? Wait, lay wululu capital. So we don't do it like this now. Okay, we can just do it's type accession, bro. But this is just that. So this will return nothing. No errors. Did we fix the code? I think we did. Fixing the code is fixing the code, bro. Double accession. Okay, let's see. TypeScript won't allow you to assert absolute nonsense. Const num42, const string num string. Error conversion of type number to type string may be a mistake because neither type sufficiently overlaps with the other. Okay. Double accession. Okay, if we have like a string, but okay, num as string. Okay, but come on. The number and sometimes they have no overlap, making this accession likely to be a mistake. So TypeScript complains. We can get around this with a double accession. So this works, but it's very unsafe. User ID as unknown as string. Oh my god. And then now TypeScript treats this as a string. User ID compiled but still crash. Oh my god. So what's the use? I've never used this in production code. If you see this in the wild, pray that the author was a 100x engineer that knew what they were doing. I mean, like, it still crashes so in runtime. So like we're just avoiding compile time errors. Why is double accession usually better there? Because you should have used what? Yeah. You should have used the camel anyways. Yes, because of potential accession to be incorrect types causing runtime errors. Yeah, this is true. Because it's root to TypeScript, yes, this is true. Because it results in slow compilation times. So 1, 2, 3 are true. This one for slow compilation times, I don't know. But 1, 2, 3. If you've used OCaml, it will cause runtime error, and then it's root to trick TypeScript. Those are true. Both are true. Non-null assertion is common for TypeScript libraries to assume that a value can be null or undefined, even when you know it can't be. You can assert that it's not with the non-null assertion operator. It tells the compiler that a value cannot be null or undefined, even when the type system thinks it might be. So import get clean text and text from this file. The clean text, get clean text, it's a function which takes in some value. Clean text is string or null. But we know that it cannot be null because we passed in a valid string. Syntax expects a string, so we use a non-null assertion. Syntax okay, what's the exclamation mark? Okay, so the non-null assertion is the exclamation mark. You also see this fairly often when you're working with optional properties that you know exist. So optional properties, then we don't control the user type. It's imported from a library, but we know that we always use the name property. So we'll do that. So it's just telling TypeScript that this can't be null or undefined, I guess. I mean, what if it is? The same rules of thumb as the same rules of thumb as assertion apply. Emo, whatever that means. Only use non-null assertions when you're crazy confident that the value can be null or undefined. Just use a conditional guard clause if there's any uncertainty. This is always safer, albeit more verbose. The function sends safety text string. If text is null, they will throw an error. Then, yeah. This is what's up. Assuming,